So this is the next teaching video, still talking about homework 1 as far as Math 140 goes. And we'll, if you want to refer to a section of the book, I think I had this written on the last video, but didn't say anything about it. This is really talking about material covered in sections 5.4, 5.5, 5.6, and 5.7 in the ebook. So we're still talking about simplifying expressions. We're not doing any solving. We're actually not even doing any evaluating yet, although I think in your homework there'll be some evaluating questions. So remember, the difference between evaluating and simplifying really is nothing except for often an evaluating question, you're given an expression with variables in it, and they tell you to evaluate the expression, and then they give you some values for the variables. In this case, in this video, we're going to talk about just simplifying expressions that have variables in them, and we don't know what the variables are. So the main emphasis of this video, though, is like terms. So we all know that you can add 3 plus 5 and do 5 minus 7. We know how to handle numbers like that, right? 3 plus 5 is 8. 5 minus 7 is a negative 2. We can even multiply, like 5 times 6 is 30. And, you know, things like that. But what happens when we start getting some variables involved, okay? So that's what this lesson is about. What do we do with variables? So for example, if I have 3x plus 5x, I think I did an example like this in the last video actually, but 3x plus 5x, because they are like terms, meaning that the coefficient is different, but the power, the variable and the power are the same. So 3x plus 5x are like terms. 3x plus 5x squared, these would not be like terms. So you can add 3x plus 5x together, but you cannot add 3x plus 5x squared together. Or 3x plus 5y. Those cannot be added together. Or, for that matter, 3x plus 5. Because remember, the number is really just counting how many of something I have. This says I have 3x's. Here I have 5x's. So it just stands to reason that together I have 8x's. So that would be 8x. Here I have 3x's, and here I have 5x squareds. Well, an x squared and x are a different animal. So this means that I have x plus x plus x, really. That's what 3x means, right? And this means that I have x squared plus x squared plus x squared plus x squared plus x squared. And obviously, if I try to add those together or simplify them, the best I can do is I have 3 of these and I have 5 of those. And I can't combine that anymore. Same way here, I have 3 x's added together and 5 y's added together. Well, the only shorter way to write that is just 3 times x plus 3 times y. Okay? And when I have 3x plus 5, this really means I have 3 x's and 5 1's, if you will, if you wanted to, for that to mean something, right? This, I have 3 x's and 5 1's, which, of course, 5 1's is just 5. Okay? So we need to understand like terms. So if I have a couple of things like, say, 3x plus 5 is an expression, and I want to add this to this other expression, 4x squared minus 7, okay? If I want to add those two together, I can do that, but I have to consider the like terms. So in other words, can I add 3x to anything else in here? Well, I can't add 3x to 5, obviously, because that's measuring x's and that's counting 1's. I can't add it to 4x squared because that's counting x squareds, not x's, and I can't add it to 7. So this is just going to be 3x. What about 5? Can I add that to anything else? Well, yes, 5 plus negative 7 I can do, right? 5 plus negative 7 would be negative 2. And then there's also this 4x squared there. It hasn't been handled yet. Can't handle that. There's nothing to add that to. So I could just write 4x squared here. The 7 has already been incorporated into the 5. Okay. Now, generally, when we're writing an expression like this with different powers, it looks nicer to rewrite it in descending power order. So that would be 4x squared plus 3x minus 2 would be the proper way to write that. Okay? And just to give you another example, if I have, for example, 3x squared plus 4x minus 2 and I want to add that to 5x cubed plus 7x squared plus 8. Okay, so again, another way to handle this is just kind of go through and ahead of time recognize like terms. So I might go through and say, okay, there's an x squared there, and there's an x squared there. There's a 4x there, and no 4x's or no x's anywhere else. There's a -2 there, and a negative and a positive 8 there. Those go together, and of course it's different. Or we can even use highlights, right? If we don't like if the underlines are confusing. Some of you like to carry different colored pencils and stuff like that. You could go, oh, there's an x squared term there, and an x squared term there, and use a different color. There's a number by itself and a number by itself. And then if I wanted to keep going, there's a 4x there, but there's an x term there with no other x terms. And there's an x cubed term with no other x cubed terms. So in this case, they're color-coded into the ones that I want to add together are the same color. So I could go recognize that there's 3x squared there and 7x squared there, so that would be 10x squared. Oh, and there's a 5x cubed. We'll put that up front. 5x cubed. Okay, so I took care of that, took care of that, took care of that. There's a 4x and nothing else that goes with it, so I'll put plus 4x. And then a -2 and a positive 8. If you add those together, you get a positive 6. And that would be the simplest form of that expression. Okay. Something to keep in mind with subtraction. If I had that same problem, 3x squared plus 4x minus 2 minus 5x cubed plus 7x squared plus 8. Okay, now if I'm subtracting this expression from that expression, got to be careful. We could go through and do the same thing. We'll go blah, 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 do yellow, and so we can recognize the like terms because we don't want to do anything but we don't want to mix terms. So there's my -2, my positive 8, and I think I said green was that guy, right? So then when I go to combine them, I'm actually subtracting them now instead of adding. So this is going to be 3x squared minus 7x squared. So that would be a -4x squared. And again, I forgot my cubed. Notice this is there's nothing over here, but I'm subtracting 5x cubed, so this would be a -5x cubed. Okay, so we took care of that, that, and that. And then we have a 4x here, and I'm subtracting nothing from it, so that would still just be 4x. And then I have a -2 minus 8, so that would be a -10, because I'm taking a -2 and I'm taking away 8 from it, so I'm going further in the hole. So that would be -8 minus 10, or -2 minus 8, which is -10. So that would be my simplified expression. Okay. Now, what happens when we start mixing multiplication and addition together? So if I have, for example, 3x times 4x squared plus 7x minus 5 or something like that, right? So normally, if we follow the order of operations, we would have to do all this stuff inside the parentheses first, of course. But I can't combine 4x squared and 7x because they're not like terms, and I can't subtract 5 from either one of those because they're not like terms. So is this the simplified form? Well, no, we have this thing called the distributive property, that if you have something on the outside of the parentheses being multiplied, you can drop the parentheses if you multiply the 3x by everything on the inside. So in other words, I have to multiply 3x times this, 3x times this, and 3x times that. So that means I'd have 3x times 4x squared plus 3x times 7x plus 3x times -5. Okay? And of course, 3x times 4x, this is, in the last video we talked about this. This is really just 3 times x times 4 times x squared. So I can multiply them in any order I want. 3 times 4, of course, is 12, and x times x squared would be x cubed. Likewise down here, I got a bunch of things multiplied together. I can do them in any order I want. 3 times 7 is 21. X times x is x squared. And lastly, but not least, down here, I have a negative 5 times a 3. That's negative 15 times x. And so I just bring along the x. Okay, so that's multiplying. We're really applying the distributive property there. Okay. We can also actually divide. You may have seen something like this where I have 4x squared plus 7x, minus, sorry about that. And I'm going to divide that by 3x. Okay. Well, once again, remember the fraction bar is kind of like a grouping. Well, it is a grouping symbol, which means I'm supposed to do all this stuff on top first and then divide by 3x, but I can't because I can't combine the 4x squared and the 7x or the negative 5. So what I can do is just distribute the 3x, but this time I'm dividing, not multiplying. So this would be equal to 4x squared divided by 3x plus 7x divided by 3x minus 5 divided by 3x. Oops. Okay. And if I wanted to simplify this, of course, one of those x's will cancel out, so that'll leave me with 4x over 3 plus the x's cancel out completely, so that'd be 7/3 minus 5 over 3x. I can't simplify that any further. Although I could rewrite this. Now listen, I'm not simplifying right now. I'm just rewriting it a different way. Don't have to do this. You could rewrite this as 4/3 times x plus 7/3 minus, now be careful here, that x is on the bottom. We can't just bring them up to the top. So you could write this as 5/3 times 1 over x if you wanted to. Don't really see a reason to do that. I personally would just leave it like this. But I know some of you will want to do this, so I'm making sure you understand how you would do that. Or this one you could write as 4/3 x plus 7/3 minus 5/3 times x to the negative 1, right? Because 1 over x is the same thing as x to the negative 1. Okay? Pretty cool. Notice that none of the numbers can divide it. If this would have been a 2x, for example, if we would have had 4x squared plus 6x minus 8 divided by 2x. Well, let's change this. Let's do 4x cubed, 6x squared, and 8x. So in this case, notice the 2x will go in there evenly in all the terms. So if we divide 2x into each one, you'd end up with 2x squared plus 3x minus 8, wouldn't you? Because notice that x factors out or cancels out in each case, and the 2 divides into 4, 6, and 8 evenly. Okay? So that's simplifying, paying close attention to like terms. So we always have to ask ourselves, are these like terms? And we can add and subtract them if they are like terms. We cannot if they're not. Now notice that the like terms don't matter when I'm multiplying. If I have 3x y z, there's a little shout out to the homework system, times 8 p q r. Okay, those are clearly not like terms. They have completely different variables, and we'll throw a squared in for fun or something here, right? But because we're just multiplying, remember this is just a multiplication problem with a whole bunch of things being multiplied together. We can multiply any order we want, so we can multiply 3 times 8, which is of course 24, and we can't multiply any of these other things because they're all variables and we don't know what they are, don't know what their value are. So we'd have to just follow up with an x, a y, a z, a p, a q, and an r squared. Does it matter what order we put the variables in? It sure doesn't. Could we have written this as, could we have written this as 24 x p q y z r squared? Did I get all of them? 1, 2, 3, 4, 5, 6? Yeah, that's the same thing. It doesn't matter. Okay, so that's One step further, sometimes we might multiply an x plus 2 times a 4x squared minus 5. So notice in this case, I have two different parentheses, and I'm supposed to do the stuff inside the parentheses first in both cases, but I can't add x to 2, and I can't subtract 5 from 4x squared because they're not like terms. So am I stuck? Do I have to just leave it like this? No, once again, we can use our friend the distributive property, which tells us that if we multiply everything in this term, or in this parenthesis, by everything in that parenthesis, you can actually go ahead and multiply it first. So in other words, we'd have to multiply x times that and x times this, and it'd have to multiply 2 times that and 2 times this. So x times 4x squared would be 4x cubed. X times negative 5 would be negative 5x. 2 times 4x squared would be positive 8x squared. And 2 times negative 5 would be negative 10. And just because, to make it look nicer, this is simplified. I can't combine any like terms, but I feel better if we rewrite this in descending order. Okay? So that would be my final answer after that. Okay? So that is simplifying expressions, paying close attention to like terms. Now, again, I talked in the first video about not doing problem recognition. So when do we have to pay close attention to combining like terms? Well, anytime we're simplifying an expression that involves variables and we're being asked to add something together. We cannot add two things together unless they're like terms. Now, back in the day in kindergarten through, say, 5th grade or 6th grade, we didn't have any variables, right? So you'd say 3 plus 5. You didn't have to worry about like terms because everything I could possibly add together was like terms because they're all numbers. But since you've entered into the realm of algebra, we have to be careful of that. So when we see an expression with variables in it, we have to think about, before we just start adding anything we want to, we have to consider, are we adding like terms or not? Oops. So anytime you have an expression that you're being asked to simplify, it's really, you have to pay attention to that. The same things we learned last video in handling exponentials or exponents correctly. When do we have to do that? Anytime you have an expression involving exponents and you're being asked to simplify or to evaluate, you have to pay attention to how you handle those exponents. Let me see, let's throw something here like 4. So once again in here, we're looking for like terms. 3x and 5x are like terms, so that would be 8x. And notice there's no other like terms, so these guys would just come along for the ride. There's nothing we can do with them. Okay? So that's simplifying. Now, just to bring the point home, so this is simplifying. What if we had 8x plus 6x squared minus 4y squared, and I said simplify? You would say, done. There's nothing else to do, right? Because that's the simplest form. Now, what if instead I said evaluate when x equals 1 and y equals 2. Okay? So now I'm, like I said, evaluate and simplify are asking you to do kind of the same thing, where you're trying to simplify the expression down to one number if you can. But in this case, I couldn't because there's the variables in there and I don't know what the variables are. So when I was asked to simplify, I just basically took it from here down to here, right? And that's all I could do. But then in another problem, you're being asked to evaluate that same expression when x is 1 and y is 2. So now I can do more because I can replace x with 1. I can replace x with 1 again, and I can replace y with 2. And now there's a lot more simplifying I can do, right? There's things I can multiply together, things I can add together. So for one thing, everything's like terms now because they're all numbers. And there's some things, so I can just go to work again. So this is going to be 8. That's going to be 6. That's going to be 2 to the third power is 8. 4 times 8 is 32. So I have 8 plus 6 is 14. 14 minus 32 would be negative 18. Okay? So that would be the value of this expression when x is 1 and y is 2. Notice if x and y were something else, then the value of this expression would be different. Okay, but this is the value of that expression when x is 1 and y is 2. All right. Let me know if you have any questions, and have fun.